Hello everyone, this is Henny and welcome to my channel. This is the second lecture of the course MATLAB for beginners. Today we are going to speak about variables, vectors and matrices. For today's lecture, there are going to be a small theoretical part that is required if you are not aware of variables, vectors and matrices. But if you know them or if you don't feel like it, then just skip this part. In the second part of the lecture, we are going to practice with MATLAB. So the first part is theoretical. It's not very important if you know it. And the second part is practical. So it's up to you to listen to the theoretical part or just skip it. Now let's get started. So variables. Variables are essential to any programming language. And MATLAB also has variables. So what is a variable? Imagine a variable as being a storage location. In this storage location, we have data that we want to store. And this storage location has some attributes. So it has a name. So we call it X, for example. So we say that this variable is named X. And it has a memory address, which looks similar to this address. And it has a size. And the size here means how much data we can put inside this storage location. So for example, we can have a size of 1 byte, which is 8 bits, or 2 bytes, which is 16 bits. And at the end, the last attribute is the value that we want to store in this variable. Now, if you wonder what are the bits and the bytes, basically 1 bit stands for binary digit. You can think of this also as a storage location that can contain only 1 digit, and this digit might be 0 or 1. It cannot contain 2 digits, it contains only one of them, and the 2 digits must be either 0 or 1. It cannot be 2 or 3 or whatever. That's why it's called binary digit or bit. But what is a byte? A byte is 8 bits. So if we have 8 cells, each of which contains 1 binary digit, either 0 or 1. If we have them together, these 8 cells make what is called byte. So this is basically a byte that contains zeros in all the 8 bits. Now in our daily life, we deal with decimal numbers. Decimal here means numbers from 0 to 9, and then we repeat with 10, 11 and so on. So the base of those numbers are from 0 to 9, 10 digits. For example, when we consider the number 5 or 6 or 19, those numbers are composed of digits from 0 to 9, and then we repeat to make other numbers, like 99 is composed of the digit 9 and 9, so we have 99, and so on. But machines like computers know only zeros and ones. Machines do not know anything about decimal numbers. We have to make some transformation between our daily life numbers and the numbers that are understandable by the computers. To do that, we use some kind of representation or encoding. In this encoding, we want to represent our decimal numbers in terms of zeros and ones. So if we have 8 bits or 1 byte like this, and we need to store a decimal number, 0 here is a decimal number because it belongs to the numbers from 0 to 9. Then how to store that? We have to fill all the cells or all the bits with numbers. We are going to start with the first representation. The first representation is to have all the bits being zeros. We are going to call this our decimal 0. Now, what about our decimal 1? We are going to make change for one of the bits here. So the last bit. So the last bit is going to be 1, and this is going to represent the number 1 in the decimal system. What about the number 2? We're going to make another change. So we make this as 0 and this as 1. And so on, and we can repeat this again and again and again. So for example, if we take the number 98, 98 could be represented in this way. And we do this again and again until we end up at the state where we have all the bits containing ones. And this is a number 255. So basically, if we have 8 bits or 1 byte, we can represent numbers from 0 to 255. But what if we want to represent numbers that are beyond the 255? Then we need to increase the size of our variable. So instead of being 8 bits or 1 byte, we might have it as 2 bytes, and then we increase the 8 bits to 16 bits. Then the representation is going to go far beyond 255. Now you can see that if you want to store larger numbers, we need larger size of the variable. But people, instead of saying give me 2 bytes or 3 bytes or 4 bytes, they make synonym for the size of the variable, and this synonym is called the data type. So instead of saying give me 1 byte or 2 bytes, instead we can just say I want this variable to be of this data type. And what is a data type? It is an attribute for the variable that is corresponding to the variable size or the memory size that we want to allocate for this variable. So as an example, if we want 8 bits to represent integers, we could say that our data type in MATLAB is uint8, which stands for unsigned integer of size 8 bits. Now, if you are new to MATLAB, you don't have really to worry about data types because MATLAB is very flexible, and usually it will choose for you the most suitable data type. That was just a simple background about variables and data types. While we dive deep in this course, we are going to speak more about data types and variables. Let's now speak about vectors. If you have a good knowledge about linear algebra or math in general, then you would understand what vectors are. However, if you lack the knowledge of mathematics, I can give you a very light background about vectors. You can think of vectors as a collection of data, such as numbers or characters. And the data in this collection of data is somehow connected to each other, such that we can have some common operations performed upon them. For example, we can think of 3 variables, x, y, and z. Those 3 variables could, for example, represent the movement of someone from one place to another in 3-dimensional space. In such case, if we want to multiply each variable by 5, and this is somehow a common operation that is applied to the 3 variables, we could do this in 3 lines of code. We can say x times 5, y times 5, and then z times 5. But wouldn't it be easier if we store the 3 numbers in one container? This container is going to be named u, and this container u is actually a variable. This variable is representing a vector of data 3, 5, 1. And then if we want to have a common operation to all the 3 numbers, we can just multiply u by 5. Now, someone will say, give me a real example, something that we really use in our daily life. Imagine that you are in a class of 500 students and you are one of the students, and your professor wanted to increase the grade by 10%. If the professor chooses the first approach, he is going to have 500 of rows, and for each row is going to multiply by 10% of the original grade. But if the professor was smart enough, he is going to have all the data, all the grades of the students in one vector named grade, and then multiplies it by 10% of the original grade vector. So this is a very easy example. Throughout the course, we are going to have more examples that highlight the usage of vectors. Now, before we leave vectors, there are 2 types of vectors. The first type is called row vector, in which the data are grouped horizontally, like this example. And there are column vectors, in which the data are grouped vertically, just like this example. If you know about linear algebra, this concept is going to be easy for you. Now, the last element of this theoretical part is going to be the matrix. A matrix is a group of data that are connected together, and instead of being in a row or column, the data are represented in two-dimensional space. So you have rows and columns. A very basic example that comes to my mind is the image. If you think of an image is composed of rows and columns. And if you know a little bit about image processing, you know that the image is composed of pixels. And the pixel is basically one storage location that contains one number. This number is representing the brightness or the color of an image. So you can imagine that this matrix here is one image. Consider this kind of operation. You would like to increase the brightness of this image here. So if you want to increase the brightness of the whole image, you want to apply some kind of operation to all the pixels in this image. We can have an operation in which we add a specific number to each element in this image. So this is the same situation that we have with vectors. So a group of data that are connected together, and we need to apply one or more common operations to this collection of data. That's why we need to use matrices. This is the last point in this theoretical part, and now we are going to go back to MATLAB and practice some code. Now back to MATLAB and back to the command window. We are going to run a few codes before we start writing our first script. Let's start with creating a variable. So when we create a variable in any language, in any programming language, we have what's called initialization and assignment. Initialization happens when we reserve a piece of memory to our variable. In many languages, we state the data type and then we give the variable name and then end the statement, and this is what's called initialization. In MATLAB, it's different. We don't define the data type when we initialize, and we have also to assign a value to this data type. So a variable in MATLAB could be created like this. If we have a variable x, we say x assigned a value, and this value could be 0, for example. And then again, we can add semicolon if we want to prevent the output, or just leave it if we want to have an output. Writing the output or not to the command window or to the screen does not change the fact that we have a variable x and it has a value 0. So this is how we create a variable in MATLAB, and MATLAB is smart enough to know the data type based on the value that we give. For example, we can have a data type that is string or character, for example. So we can define another variable y and we assign it the value hello world, just like that. And for a string or text in MATLAB, we have to put our string or text inside the single quotation marks. So enter. Now we have a variable y that contains the string hello world. And we can see here that the icon besides the variable name looks different. So we have ch in 2 cells instead of a matrix like an x. What does this mean, or what does ch stands for? If you hover over y here, just like this, you are going to see the data type. So it's 1 times 12 character. That means we have a matrix or a vector that contains 1 row and 12 columns, each of which contain 1 character. Okay, so this is how we create variables. There are few rules about the naming of a variable. First, variable names must be composed of only letters, numbers, and underscore. Nothing else. You cannot have a symbol like this, for example. This cannot be used in variables. So if we write this symbol and another symbol and so on, and then xyz, and then xyz, this is not a valid variable name. You will not see an error because this letter here is used for comments. So anything comes after this symbol is a comment, so it's not seen by MATLAB. So there is no error in this statement. But if you take another example, like when you write the $sign and write IJK, for example, and try to assign it a value 8, there will be an error. So remember, variable names must be composed of only letters, numbers, and underscore. The second rule, you cannot start with underscore or numbers. You have to start the variable name with letters. So you cannot say, for example, underscore x equals 5. No, not valid, right? But you could say x underscore y underscore z, and then 1, 2, 3, assigned the value 9. That is valid, right? I'm going to clear or clean the command window, right? So this is how we create or initiate variables and assign values to them. Now, I want to speak a little bit about variables here. I have seen lots of people thinking that MATLAB stands for MATLAB. No, it's not true. MATLAB stands for Matrix Lab. Why Matrix Lab? Because everything in MATLAB is basically a matrix. So just let's clear the workspace. If you have a variable x assigned 5, in fact, you think about 5 as just a single number or a scalar, but in fact, MATLAB considers it as a matrix or a vector of size 1 by 1. So it's one row, one column. So everything, all the variables in MATLAB are going to be vectors and matrices. And because of that, you can write x assigned 5 just like this, or you could choose the square brackets. So we always use the square brackets. It's a must if you want to create vectors or matrices, unless the value that you want to assign to a variable is one single value or scalar. However, this one single value or a scalar is a vector or a matrix. So you can just say x assigned 5 like this. So we have x assigned 5, and if we hover over x just like this, we are going to see 1 by 1 of type double. 1 by 1 of type double means we are having a vector or a matrix that is one row, one column, and the data type inside it is just double. Make sense? Now, if I want to have a variable y, I can just say open bracket 6 close bracket, just like this. Now, if you look at the workspace, x is a variable that contains a value 5, y is a variable of the same type. The only difference is the name, and it contains the value 6. Remember, we can redefine x, so we can just say x assigned 1, 2, 3. Okay, so now we have a vector. X becomes a vector, and if you hover over x, it becomes one row, 3 columns of type double, and it has the values 1, 2, 3. We saw here that we have a separation between the first element and the second element by the space, but we can also have this kind of separation between elements by a comma. So 1, 2, 3, and then we can add 4 just to change the size. X becomes a row vector of 1 row and 4 columns, and it contains 1, 2, 3, 4. So space and comma are the separator for row vectors. Let's see the column vectors. So y assigned the values 1, 2, 3. If I have it just like this, then this is going to be a row vector. That is a collection of data that are grouped horizontally. But I want this to be a column vector that is a collection of data that is grouped vertically. Then the separation is going to be semicolon. That's it. So y becomes 1, 2, 3, a collection of data that is grouped vertically. I'm going to clear my screen. So I have a vector x and a vector y. X is a row vector, y is a column vector. There are several operations, mathematical operations, that we could apply to these two vectors. For example, we could have the transpose operation for x or y. So the transpose is basically for a vector is to convert it from row to column, or from column to row. So basically we are rotating the vector by 90 degrees. Either being, if it's a row, it becomes a column. If it's a column, it becomes a row. If we write just x like this and we have x in our workspace, x here is going to call the values of x, just like this. So we have x 1 2 3 4 as a row vector. Now if you want to make x a column vector, we could either redefine x to be 1 semicolon 2 semicolon 3 semicolon 4, just like this, or easier than that, we can just say x assigned the transpose of x. X is assigned the value x and then the single quotation mark. So single quotation mark is a representation of the transpose. So this becomes column vector. We basically rotated the vector x by 90 degrees. We can try the transpose of y. So we can say y assigned the original value of y after being transposed. So it's going to be 1 2 3, just like this. X becomes column vector and y becomes a row vector. Now let's take an example of a matrix. If you want to have a matrix is composed of rows and columns. Remember that when we defined x, we separated its values by a space or comma. And here 1 2 3, and here x is being a row vector. Now considering y being a column vector, this is the first row, and when we want to add another row like this, we need to separate by a semicolon, right? Now if you think about these two, we can create a matrix based on these definitions. So we can have a matrix A, and A in general is composed of rows and columns. So we want to separate rows by semicolon and separate columns by comma or space. And so we're going to have values like 1 2 3. So then we have the first row that contains 3 columns, and then we add the elements of the second row. So for example 4 5 6, and they are separated by space. And if we want to add another row, we separate by a semicolon, and we could just say 7 8 9 and then close the bracket. Now we have the matrix A. So A is a matrix of type double, that is 3 by 3. Again, we can have the transpose operation on A just like this. We can say A and then the single quotation mark. So you can see that one is the same, but now if you go to the second element of the first row, which should be 2 here, it becomes 4. Why 4? Because 4 was here. So we made a rotation by 90 degrees around the central element 5. So let's say that we have the matrix A. If we want to select the element here, 5, the element 5 here, which is the second row and second column. So if you want to do that, we can just call it by A and then open parentheses and then add 2 and 2. So A at 2 and 2 is going to give me the element 5, just like this. To select any element in a matrix, we have to go to its location in terms of rows and columns, right? Now, if you want to do the same with vectors, so we have x 1 2 3. If we want to select the last element, we can say x at 3. Okay, so we have it 3. Some of you would say x at 1 and 3. This is valid because x is considered as a matrix. When you access it by the row and column, we have 3 at the first row and at the third column. So that is valid, but it's short to just say x at 3 or x at 2, for example. You could do the same with y, which is a column vector. And if you want to access, let's say, the third element, it's going to be y at 3, right? But if you want to access it using the matrix notation, so you're going to give it the row and column, you have to make sure that you're given the right indices. So 3 here is at the third row and the first column. So you say 3 and 1. What if you make a mistake and say y at 1 and 3? We don't have a third column at the first row. So the first row is here. It's composed of only one column, we don't have values here or here. Okay, so this is not valid. Okay, so it says index in position 2 exceeds array bounds, must not exceed 1. Why 1? Because we have one column only. Consider A. The matrix A is composed of 3 rows and 3 columns. What if I want to select the upper sub matrix here? 1, 2, 4, 5. What if I want to do that? We use the colon operator, this operator. The colon operator is used between the first and the last elements that I want to select, and we select all the data between them. So if I want to select the elements 1, 2, 4, 5 as a sub matrix, A underscore sub A at 1, 2, 2, for example, comma, and 1, 2, 2. So here you have the index for the row, which row you are trying to access, first row and the second row, and which columns you want to access here. So I'm going to access the first column and the second column, so this one and this one. So that means I'm going to select 1, 2, 4, and 5, right? 1, 2, 4, and 5. Now let's take another example in which we want to select the first 2 rows of A. So to do that, we would say A at 1 to 2 and 1 to 3. So we want the rows from 1 to 2, so that's this one and this one, and we here write, and we write here the range of the columns, so from 1 to 3, so this one, this one, this one. So we are selecting 2 rows and 3 columns. So yes, that's true here. And because the colon operator selects a range of data for us, it's called sometimes the range operator, right? We can have another example by having 2 columns and 3 rows. That means I'm going to select A from 1 to 3, and the number of columns, we can choose the last 2 columns, this one and this one. So that means from 2 to 3. So I'm going to have these 2 columns, 2, 3, 5, 6, 8, 9. So let's see. Yeah, 2, 3, 5, 6, 8, 9. Here we are calling the values. We are not creating a new variable. Whenever we do this, a variable is created for us and it's named ans. I think that stands for answer. And this variable is a temporary variable. So whenever you have a call to a function or a command, and this function or command result in some values, and there are no assignments for those values to some variable, there will be a temporary variable named ans created for you, and you can see it here. And this one is changed from time to time. So whenever you have this kind of calls, you will have ans modified. Now let's clear the screen. I'm going to have more examples that uses the range operator. For example, what if I want to select all the rows but some specific columns, right? So in A, for example, give me the range from 1 to 3 because I know that A has 3 rows, and then I'm going to have the second column only, okay? But I can do this in a different way. I can just use a colon operator without a start and end, just like this, A, and then a colon operator that stands for everything, all the range from first to last, and then I'm going to have whatever columns I want. It gives me the same result. So I can use a colon operator with first and last indices, or I can have it without indices to indicate all the range, right? And if I call A with colon and colon here, that means I'm having all the range for the rows and all the range for the column, and this is equivalent to the whole matrix A. So it's A, right? So this one, this call is equivalent to this call, A at the full range and the full range, right? Now if I want to select a range of data, and let's say I'm going to select it from the index 2 or 3 up to the end, right? So let's have another matrix, a bigger matrix, D, for example. and then this matrix D consists of 5 by 5 elements, right? So to do that, I can create the 5 by 5 elements just like that, just random elements. Okay. Yes, okay, 5 by 5 elements. And let's say I want to select this row and this row, okay, this the second row and the third row, okay. And let's say in the second row and the third row, I'm going to start with the second column. To do that, we can say D from second row to which row? Second row, and the third row, okay, to the third row. And I want columns to be from the second column up to the last one. So we can just say from 2 to 5, right? Okay, from this column to this one. So 2, 3, 4, 5. Okay, I could do it in a different way. So let's say we have a matrix that I am not sure about its size. Okay, so I know that it might be 5 rows, 5 columns, or maybe more or less, but I always want the last column with me. Okay, so from 2 to the last, I can use the keyword end. So I can say D from 2 to 3, okay, and then from 2 to end. End here represents the last column, and you can also use it with the row. So instead of saying, for example, from 2 to 3, you can say from 2 to end, right? So you have here D from 2 to end, so that means from this row to the last one, okay? And then we have the columns from 2 to end, so that means from this column here to the last one. So now let's get to another usage of the range operator, in which we can use the range to create a vector of data or a matrix of data. So as we have seen in the first lecture, we created a vector x from 1 to 10 and the vector y from 1 to 100. So we can do that again here. So we can define x as being a vector from, let's say, 1 to 10 here. Okay, so I could do that. So this is a basic way how to create a vector of data based on a range, and this range starts at 1, the first element, and ends at the last element. Now if I want x to be incremented or separated by certain values, I can add it to the range too. So I can say, give me a vector of data from 1 to 10, right? But I want the difference between the first and the second element to be 0.1. So I need to add another column operator, and in here I'm going to write the increment value, or the difference, okay, between the elements, or the step size, if you want to call it the step size. So 0.1. Okay, so now I have all those elements. So the first element is 1, the second element is 1.1, and then 1.2 up to 10, and they are separated by 0.1 and so on. Okay, so this is how we also could use the column operator. We have seen that writing commands here in the command window is a little bit messy, so it's lots of data that are output to the screen, and from time to time you have to use, or you should use, the CLC, right, to clear the command window. So instead, and if you want to have some kind of organization in your code, you can write your codes in a script file and run them all by a call or just by one click. How we do this? We can just create a script file here, and later I'm going to show you in a different lecture how to create a function. But to create a script file, you can just click here, right click here, and choose new script, right? And then you can name it anything. You can name it, for example, my first code. So my first code, right? And then you can open it, So when you open it, you could have it here just above the command window and write whatever you want, or you can undock it. Okay, I usually like it to be undocked, but it's up to you. I can just I'm going to just bring it back, okay, to the main view. So in here you can write the same scripts that we have written in the command window, but when you finish writing all the commands and then you press here on the run button, it's going to run everything in this script. Let me clear my workspace. So from the command window here, I can just clear my workspace. So I have nothing here. So now let me create a vector x, right? So this vector x is going to be the values from 1 to 3. Okay, this is my vector x, right? Now let me create in the second line a matrix A, right? And a matrix A is going to take those numbers 1, 2, 3, and then 2, 3, 4, or 5, and then 2, 3, right? And if I leave this without a semicolon, I'm going to have A written to the command window. I'm going to just have the semicolon. And now I would like to run the multiplication between a matrix and a vector. Remember, if we want to multiply a matrix by a vector, we have to have the number of columns in the matrix must equal to the number of rows in the vector. If I want to multiply A by X, I have to have the number of columns in A. So how many columns we have? 1, 2, 3. Okay, must equal the number of rows. X here is one row only. So what we could do here is just say X assigned X transpose. So what happens here is that we are going to have a temporary variable that you don't see and takes those values from 1 to 3, which is 1, 2, 3, okay, and then makes the transpose of X, assign it to this temporary variable, and then it will assign it back to X. Now I could have B as a vector equals to, or assigned B as a vector assigned A times X, right? So let's see how it works. I'm going to save this first, and then I'm going to run. Now when I run, I can see here the word my first code, which means that this file here or this script was called, right? Now, do I have in my workspace the variable B? Yes, I have it. So if I want to see the values of B, I can write here. So it's 14, 23, 19. So this is the result of the multiplication of the matrix A by the vector X. We have seen that we have a rule for the multiplication of a matrix. So if you have a classmate that does not know about mathematics or linear algebra, and it happened that this guy is looking at your code and does not understand what happens here, why you do the transpose, you can write for him some documentation or some comments to let him know. We write it using the percentage sign here and write whatever we want. This line is not, it's going to be ignored by MATLAB. MATLAB is going to just leave it like this without running it. So you are free to write whatever you want. So you can say here, note to multiply a matrix by a vector, the number of columns in the matrix must equal to the number of rows in the vector, right? So this is a very basic example showing how to write script or a bunch of codes and save them in one file and how to run them at once. At this point, we came to the end of this lecture. I hope the information in this lecture was useful. And if you like this video, please try to share and subscribe to that channel. Also, if you have any question, or if you want to bring up a subject that I can explain in another video, please write that in the comments. Thank you for watching and hope to see you next time.